Application of differentiation, part 6. Starting from this video, I would like to discuss some real-life example on how to apply the differentiation in our daily life. The first application is related to rate of change. Maybe some of you do not know the concept of rate of change. That means I want to find the variable change per time. One of the typical example is velocity. What is the velocity of a car is 25 km per hour. That means this car changed the displacement per time is 25 km per hour. That means in 1 hour, this car can change the displacement of 25 km. So let's see the formula of velocity. Is change of displacement over time. Because we have already discussed the concept of limit, that means we can take delta t tends to 0. Delta s over delta t, so this is ds over dt. If you want to find the velocity of a particle p, then you can find ds over dt. Similarly, you can also make good use of dv over dt to find the accelerations. Here, one of example related to how can we make good use of differentiation to find the velocity and accelerations. Okay, read the question first. If we have a stone and then fall upward to a build from the top of building, that means if we have a building, we throw a stone from here and then fall down. What is the height of the building? What can we do? Because I know the height of building, that means when t is equal to 0, this is the height of the stone is equal to the height of building. So part A, when t is equal to 0, then s is equal to 75 meter. Okay, this is the height of building. Part B, find the velocity at which the stone left the top of the building. That means what is the relationship? What is the velocity of t when velocity when t is equal to 0? I have one formula. Is s is equal to negative 5t squared plus 10t plus 75. I need to find the velocity. Velocity is equal to ds over dt. Remember, the base is equal to t, so I can find the differentiation directly. So this is 2t. I do not need to apply chain rule because the variables are equal. So this is equal to negative 10t plus t when t is equal to 0. V is equal to 10 meter per second. Part C. What is the maximum height of the stone can reach? If you want to find the maximum height, what is the how special when the stone is at the top, the maximum height? If you know in physics, I know the velocity is equal to 0. That means negative 10t plus 10 is equal to 0. T is equal to 1. So the maximum height is equal to negative 5 times 1 squared plus 10 1 times 1 plus 75. So which is equal to 85 minus 5 is equal to 80 meter. The last part, you need to find the velocity at which the stone hit the ground. Okay, that means you need to find the values of t so that the stone is at the ground. What can I do? I know the height is equal to 75, so that means you need to find the t first. So if you can recognize s is the distance of the stone from the ground, so if the stone hit the ground, s is equal to 0. Then negative 5t squared plus 10t plus 75 is equal to 0. Maybe you can use your calculator to factorize it. So t is equal to 5 or negative 3. So you can reject this answer. What is the velocity when t is equal to 5? V is equal to negative 10 times 5 plus 10. So, which is equal to negative 40 meters per second. Okay, maybe you can turn to next page. Try to do for exercise 11. We can discuss during a lesson, because I also want to introduce another example, maybe which is not related to speed and velocity. Okay, just like example 5.17. Okay, let's see the question first. If we have a balloon and expand at a rate, that means if we have a balloon and then it will expand at a rate 100 cm cube per second. That means in 1 second, the balloon will increase by 100 cm cube. Ask you to find the rate of change of the radius. So I want you to know what information you have and what do you need to find. You need to find the rate of change of the radius. That means you need to find dr over dt. When the radius of a balloon is equal to 10, because in different radius, the rate of change of the radius will change, so that we have a specific moment. In this case, we need to know the rate of change of the radius when the balloon, the radius of the balloon is equal to 10 cm. Okay, remember this is what we want to find. This is the information. We will use it in the last part. And we have one more information, is this one. What is this? This is 100 cm cube per second. Increase 100 cm cube. That means this is dv over dt. Okay, analyze the questions. You have dv over dt, you want to find dr over dt. That means before that, you need to have one equation related to v and r. So, what is the volume of a ball with the shape is a sphere? Okay, spheres. And this is equal to 4 over 3 pi r to the power 3. This is the relationship between v and r. So maybe you can buy differentiation both sides. With respect to t, because I want to find dr over dt and dv over dt. Left hand side, dv over dt. How about right hand side? 4 over 3 and pi is a constant you can separate, and then you cannot apply the power rule because the base, one is r and another is t. So you need to use chain rule, dr times dr over dt. So 4 over 3 pi times 3r squared dr over dt. Simplify 4 pi r squared dr over dt. Okay, then we can find the answer. Why? Because I have dv over dt, which is equal to 100. I want to find dr over dt. We have one unknown, which is r. But I want to find dr over dt when r is equal to 10. So dv over dt is equal to, 100 is equal to 4 pi times 10 squared dr over dt. So you can simplify it. Dr over dt is equal to 1 over 4 pi cm per second. Okay, remember you need to substitute r is equal to 10 in the last part, because if you have already substituted r is a 10 and then you can find the exact values of volume. This is a constant by differentiation both sides. This part will be equal to 0. So Remember, substitute it in your last part. You can use the same idea. Now I want to find ds over dt. But this time you have dr over dt and dv over dt. So maybe you can write down the formula first. A is equal to 4 pi r squared. Use the same idea. dA over dt is equal to h pi r dr over dt. Okay, I jump one step. I want to find dA over dt. When r is equal to 10, I have dr over dt at r is equal to 10. So when r is equal to 10, I know dr over dt is equal to 1 over 4 pi. So dA over dt is equal to h times pi times 10 times 1 over 4 pi. And then simplify it. This is 2, which is equal to 20 cm square per second. We may have more discussion in our lesson, but okay, this is a brief example on how can we make good use of way of change to solve some daily life questions.